Now, last class, we talked about compound interest. And last week, I think in both classes, we talked about it. And we talked about, and we alluded to the fact that if you compound continuously, if you shorten the period of compounding enough, you get P of t equals P naught e to the RT. Now, I would love to go through the details of how that comes about, but I might not have time to do it, and I'm not optimistic that our class would follow it, okay? We have good people. If I had a class full of people who wanted to be engineers, you can be guaranteed that we would do it. But for the purposes of the present class, unfortunately, we're going to omit that limiting process. So we have P of t equals P naught e to the RT. That is the principal function. P stands for principal in this case. Principal is a function of time, is equal to your initial principal. P naught is regarded as your t equals 0 principal, your principal when t is 0. Then times e to the RT, where R is your interest rate. So, two things you need to understand about this, other than the fact that this is how you calculate interest when it's compounded continuously, is that P naught is your initial investment. T starts at the instant of your initial investment, so T is 0 as you make that investment, and then time runs on. And R is your interest rate. Okay, so if your if your interest rate is 4%, then R is 4%, which is 0.04. And if you're, well, okay, we'll just go with the interest rate right now, and not put in any specific amount for the initial principal. Okay, so the question then is, if this is your interest rate, what's your function? Well, your function is P of t equals P naught e to the RT. R is 4%, and 4% means 0.04. 4 per 100 is 0.04. And be careful. I see a lot of people wanting to write down 0.4, and there's a confusion that comes about because a lot of times fairly standard notation is to do a 0 in front of the decimal. So it'd be 0.04. That's really easy to confuse that with 0.4 if you're not thinking about what it means. So you really have to think about what this means. I'm kind of ambivalent about the whole idea of putting the 0 in front of the decimal. It's not necessary, and I understand there are advantages to doing it, but the disadvantage is that it tends to confuse the notation in a way that's, I think, unnecessary. It could clarify as well, so there are arguments on both sides of the coin. I come down in, you just don't put the 0 in front of a decimal. Okay, if that's all there is. Anyhow, R, 4% means 4 per 100, means 4 divided by 100 means 0.04. So, you put the 0.04 in there where R is. There's your function. Now, the function still has room to put in your initial principal, but we can do a lot with the function if we don't have a specific initial principal. Specifically now, we have this, and we ask, how long does it take for P, your principal, to double? Okay? Well, first of all, when t equals 0, you get P of 0 equals P sub 0 e to the 0.04 times 0, which is P sub 0 times e to the 0. Now, I've got to take my class to task on this from early January, and it's now, getting toward middle April. We've repeated many times, and in the first set of exercises I gave everybody, it was necessary to understand that any number raised to the 0 power is 1. People still want to tell me it's 0, and that's simply a lack of attention to that detail. Okay? Now, that's not unusual, but we really need to be over that. Okay? Because right here, it bites you, and all of a sudden you think that's zero, so you have no basis for continuing the problem. Okay? Any number to the zero power, even 0 to the 0 power, gives you 1. It has to be that way. I could show you how all our rules or properties of exponents would be invalid if it wasn't so, but I'm not willing to take the time away from other things. You have to know that any number to the 0 power is 0. Now, if you already know that, forgive the digression, but that's something that, you know, just has to be known. Okay, so e to the 0 is 1, so that's p naught times 1, which is just p naught. So when t equals 0, this principle does give you p naught, as I claimed. Okay, p naught is the t equals 0 amount. This proves it. Okay, now, if the principle then doubles, what's it going to be? Well, it starts out at p naught. If it doubles, it's, now one answer I got was p naught squared. Well, you know, right thinking, but think about it. If you put in $1,000 and it doubles, do you have 1,000 squared? That would be a million. Well, that's not what you get when $1,000 doubles. So always kind of check yourself against some simple numbers to be sure, if you're not 100% sure. If you double $1,000, you get $2,000. If you double p naught, you get 2p naught. Now, that e on the letter B, when I just looked at it, looked a whole lot like a less than sign, so let's round that off a little bit, okay? That's a little better. Okay, so we have the fact. P starts at p naught, and when it doubles, it becomes 2p naught. So p will have doubled when p of t equals 2p naught. And the t that makes that so is how long it takes to double. Okay, well, p of t is p naught e to the 0.04 t. So you set, so p of t equals 2p naught when what? When p naught e to the 0.04 t equals 2p naught. Okay. P of t equals 2p naught. P of t equals this expression. So this expression equals 2p naught. And we have to solve that for t. How do we solve that for t? Well, we use our simple rules of algebra, and we will eventually get to the point where we have to use our rules for expressing an exponential as a logarithm. An exponential equality is a logarithm. So how do we do that? Well, let's write down the equation. P naught e to the 0.04 t equals 2p naught. Okay? So, well, we want to get from here, we want to get this to e to the 0.04 t equals something, because that would be of the form e to the a to the c equals b. Okay? And we'd be able to write that as log to the base e of something equals 0.04 t. Now, assuming we have gotten used to that kind of inversion, and at the time we did this, you know, people hadn't yet had the opportunity to do 30 problems that involve that kind of inversion. Okay? So, if you're watching this before you've had the opportunity to do the problems that precede these, you know, you might want to watch it a little later and just kind of scan through what we do here. But it's fairly easy to understand if you understand what we did in the preceding videos. Okay, what do we do to this equation to get it into this form? E to the 0.04 t equals something. Well, we want to isolate that e to the 0.04 t. We can't apply our rule until we've done that. Okay, so we've got to isolate e to the 0.04 t. How do we do that? Now, some people will tell me, nobody did in class, but somebody said, well, subtract p naught. Well, subtracting p naught doesn't work at all. Okay, you divide by p naught. Okay, if you divide this by p naught, you're going to have a p naught divided by p naught, which is a 1, times your e to the 0.04 t. That just leaves you e to the 0.04 t. Okay, so we divide both sides of the equation by p naught. We get p naught e to the 0.04 t divided by p naught equals 2p naught over p naught. Okay? And then, of course, people are going to want to start canceling stuff. I'm going to write it out here That is the same as saying P naught over P naught times e to the 0.04t equals 2 times P naught over P naught. Okay, this equation says the same thing this does. P naught divided by P naught is 1. So that's 1 times e to the 0.04t equals 2 times 1. And of course, 1 times e to the 0.04t is just e to the 0.04t. 2 times 1 is just 2. And we get e to the 0.04t equals 2. Now we have this in the form a to the c equals b, or whatever it is. Okay? It's going to be log to the base e of 2 equals 0.04t. Now I've skipped a step, but that's what you get, and once you're used to doing those inversions, you'll be able to do that very easily and correctly. And so you're going to get 0.04t equals log base e of 2, which of course is natural log of 2. So that t, well, you divide both sides by 0.04 here, don't you? T equals natural log of 2 divided by 0.04. And that equals, and I just got calculator in parentheses because you're going to need a calculator to get the natural log of 2. I'll tell you, it's around 0.7, so if you just want a ballpark, that's pretty close. But if you want to get an accurate result, you plug in natural log of t, that natural log of 2, and you divide that by 0.04. And you get about 17.5, 17.7, I think, probably pretty close. So it's going to take about closer to 18 years than 17 in order for this principle to double.